Okay, good morning, everyone. So in the last class, we had discussed about the common preparation methods of aldehydes and ketones, right? The common preparation methods of aldehydes and ketones. Do you remember any methods? Which are the common methods? Can you tell me any one method?
Oxidation of alcohols.
Yeah, oxidation. In oxidation, if it is primary alcohol, what product will be obtained?
Aldehydes.
Aldehyde. If it is secondary, Evelyn, what product will be obtained?
Ketones.
Ketones. Okay. Then another method, that is dehydrogenation of alcohols, right? What is the condition for this dehydration of alcohols to give aldehydes and ketones? What is the condition, Punya?
Volatile alcohols.
Only volatile alcohols, it can give this aldehydes and ketones. Then next method, that is from hydrocarbons. One is ozonolysis and the other one is hydration. So now we are going to learn the preparation methods of aldehydes. Okay, aldehydes. So this is the first method, that is known as Rosenman reduction. Okay, Rosenman reduction. So among these different methods, the named reactions, it's very important. So you have to definitely learn this named reactions. First one, Rosenman reduction. And it is from acid chlorides. What do you mean by acid chloride? Carbonyl group will be there. Along with carbonyl group, one halogen will be there. So here it is acid chloride. So chlorine, COCl. That will be the COClR. That is the common formula of acid chlorides. So here we are discussing about benzoyl chloride. Okay, benzoyl chloride. Benzene ring with COCl. And it's a hydrogenation reaction. Hydrogenation means just addition of hydrogen, and it is catalytic hydrogenation. Catalytic hydrogenation. So the catalyst will be there in this reaction. Palladium and barium sulfate, that will be the catalyst. So addition of hydrogen to benzoyl chloride, instead of this Cl, this hydrogen will replace the position. And the product formed is benzaldehyde. So benzoyl chloride, it's a type of acid chloride. It's on hydrogenation in the presence of catalyst, or otherwise known as catalytic hydrogenation. Palladium and barium sulfate, it will be considered as the catalyst. Okay, palladium on barium sulfate. That means the surface will be provided by barium sulfate and palladium will be there on the surface. So this complex of palladium and barium sulfate, it will be the catalyst, and benzaldehyde will be formed. Here the reaction is very simple. Instead of chlorine, this hydrogen will replace the position and it will become CHO, that is aldehyde. So benzoyl chloride, it is converted to benzaldehyde by the reaction Rosenman reduction. This is clear. The reagent is hydrogen and the catalyst is palladium barium sulfate. This is clear, children? Yes or no?
Yes, ma'am.
Yes. Please switch on your videos. Okay, so this is the first one. Shall I move to the second one? Have you completed this? Yes, okay. So the second method of preparation, that is from nitriles and esters. Okay, second method of preparation, that is from nitriles and esters. So first method from nitriles, here RCN, that is the common formula for nitriles. And here the reagent used is stannous chloride, that is SnCl2 and HCl. Stannous chloride and HCl, hydrochloric acid. So here nitrile, its common chemical formula, that is RCN. R stands for any alkyl group. Okay, CH3 or CH3, CH2, anything. So RCN, that is nitriles, it will react with stannous chloride, that is SnCl2 and HCl to form imines. Imines, RCH double bond NH. That one is known as imines. Then again, water molecule is added. That is H3O plus, it indicates the addition of water. It will give respective aldehyde. So that is the second method of preparation, that is from nitriles. So nitriles that will react with stannous chloride and hydrochloric acid to form imines. RCH double bond NH, that is the chemical formula of imines. Okay, here it is RCN, and in this RCN, one hydrogen is added to carbon and one hydrogen is added to nitrogen. Then it will be converted to imines. Clear? RCN. So one hydrogen added to carbon, one hydrogen added to nitrogen. So nitriles will be converted to imines. Then on addition of water, it will be converted to aldehyde. And this reaction is called Stephen reaction. Okay, the name of this reaction, that is Stephen reaction. So here we are using the reagents stannous chloride and hydrochloric acid. Instead of the stannous chloride and hydrochloric acid, we can use another reagent that is known as DiBALH. DiBALH. All are in capital letters. That is a short form. Its full form is diisobutyl aluminium hydride. So instead of stannous chloride and hydrochloric acid, we can use one alternative reagent, that is diisobutyl aluminium hydride. So the same reaction will take place. First, it will be converted to imines, and on the second step, by addition of water, this aldehyde will be obtained. Okay. So the reagent's name is, you have to always remember, it's short form DiBALH, D for di, then I-iso, then B-butyl, Al, aluminium, H for hydride. So diisobutyl aluminium hydride. Again, this nitriles, it will be converted to aldehydes. Clear? That's about nitriles. Then same reaction, only the change in the reactant. Instead of nitriles, we will use esters. Okay, instead of nitriles, we can use esters, and using the same reagent, DiBALH, diisobutyl aluminium hydride, we can produce this aldehyde. So look at this reaction, CH3, CH2, 9, then CO, OC2H5. So this is an example for ester. It's on reaction with diisobutyl aluminium hydride. The respective aldehyde will be formed. So this part, it will be converted into one aldehyde. Okay. So this is the second method from nitriles and esters. So from nitriles, the reaction is known as Stephen's reaction, and the reagent used is stannous chloride, that is SnCl2, and hydrochloric acid, HCl. The same reaction can be proceeded using another reagent, that is diisobutyl aluminium hydride, and we can also change the reactants from nitriles to esters. The same product will be obtained. So these are the two methods of preparation of aldehyde from nitriles and esters. This is clear? Yes or no?
Yes, ma'am.
Yes, okay. So anyone can tell me what will be the reagent used in Rosenman reduction? Rosenman reduction. Which one will be the reagent? Adul, can you tell me?
Acid chloride.
Acid chloride. Then that will be the reactant. Which one is the reagent?
Palladium and on barium sulfate.
That is the catalyst. Reagent.
Hydrogen.
Hydrogen. Hydrogen is the reagent. Okay. That acid chloride, that will be considered as the reactant. Okay. And which one is attacking on that? That will be considered as the reagent. and palladium barium sulfate, that will be the catalyst. So the name of the reaction is Rosenman reduction. And what about the name of the reaction of preparation of aldehyde from nitriles using stannous chloride and hydrogen chloride? Anna?
Stephen's reaction.
Yeah, Stephen's reaction. So which reagent can be used other than the stannous chloride and hydrochloric acid to convert this nitriles to aldehyde, Dia?
Dibal H.
What is the full form of dibal H, Malavika? Malavika, are you there?
Yes, ma'am.
Full form of dibal H. Anyone? Achyut, can you tell me?
Ma'am, diisobutyl aluminum hydrate.
Okay, diisobutyl aluminium hydrate. Then the third method, that is from hydrocarbons. Okay, third method of preparation, that is from hydrocarbons. And hydrocarbons, the first method is oxidation. Okay, first method is oxidation. So can you tell me what will be formed on this oxidation of hydrocarbons? What will be the final product? Anyone? What will be the final product on oxidation of hydrocarbons? Normally, carboxylic acid will be formed as the final product of oxidation, especially for methyl benzenes or other any hydrocarbons, because they will pass through different stages. That means hydrocarbons can be converted to alcohol, then alcohol can be converted to aldehyde, then aldehyde to carboxylic acid, aldehyde or ketone, then final stage is carboxylic acid. So if you are using any oxidizing agent, the product obtained will be carboxylic acid, because that's the final product. But we need to separate, or we need to obtain this aldehyde from this hydrocarbons. Okay, usually if you are using any strong oxidizing agent, carboxylic acid will be the product, but we need to obtain aldehyde as the product. Clear? So we will use certain specific reagents to stop the reaction at aldehyde stage. Otherwise, it will proceed and the final product will be carboxylic acid. So in order to obtain this aldehyde, we will use certain specific reagents. Okay, so here the reaction is oxidation, but we will use certain reagents. So the first one that we used is chromial chloride. Okay, the first reagent that we used is chromial chloride. Look at the chemical formula, CrO2Cl2, that is chromial chloride. If you are using chromial chloride, we can stop the reaction at the aldehyde stage. Otherwise, it will proceed and the final product will be always carboxylic acid. If you are using chromial chloride as a reagent, then we can stop the reaction at aldehyde stage. So this toluene, usually we are taking the methyl benzene, that is toluene, methyl group on benzene ring, toluene, or its derivatives can be used. So toluene on reaction with chromial chloride in the presence of CS2, that is carbon disulfide, it will be used as a solvent in this reaction. CrO2Cl2, that is chromial chloride, in the presence of carbon disulfide, first a chromium complex will be formed. Chromium complex. Complex means the addition of all that substance together. So here it is toluene, then CrO2Cl2, it is added. It is all together. Instead of the CH3, one hydrogen is there, and all other elements in this chromial chloride, it is together here, OCrOHCl2 twice. Okay, it is an addition product. All the reagents will come together. So a chromium complex will be formed. And the second step, that is addition of water. In all this reaction, the second step will be addition of water. And the product is benzaldehyde. Okay, so here the reagent is chromial chloride. In the presence of carbon disulfide as a solvent, first a complex will be formed that is known as chromium complex. It is on addition with water, benzaldehyde will be formed. And this reaction is known as ITAD reaction. Okay, this reaction is known as ITAD reaction. It's a oxidation reaction, and the oxidizing agent used is chromial chloride, CrO2Cl2, in the presence of carbon disulfide. First a complex will be formed, then on addition with water, aldehyde will be obtained. Is this clear? About the first one? Yes, okay. Then the next one, here also this is oxidation itself. Okay, all these reactions are oxidation. This one also oxidation. And the reaction proceeds in the same way, only difference in the reagent. Instead of chromial chloride, here we are using chromic oxide and this acetic anhydride. Okay, the two reagents are used in the second one. Chromic oxide instead of chromial chloride, here we are using chromic oxide, that is CrO3, and acetic anhydride, that is CH3CO twice O. And the temperature is 273 to 283 Kelvin. Here also a complex will be formed in the first step, and in the second step on addition with water and heating, this delta that will represent heating. Okay, delta sign on any arrow that will represent heating, and the same product benzaldehyde is obtained. Okay, so the second reaction also oxidation. Instead of chromial chloride, we are using chromic oxide and acetic anhydride as the reagent at 273 to 283 Kelvin. First a complex will be formed, then on addition with water, on heating, benzaldehyde will be obtained. Okay. Yes.
But here we are not talking about heating, right?
In the first one, right?
Yeah, like
first one-
hydrolysis is told, but heat.
Not hydrolysis, hydration. Hydrolysis means removal. Here we are adding water. Hydration.
No, like we're talking about chromial chloride, right?
Yes, chromial chloride. Second one. Chromic
Okay.
oxide now, chromic oxide. In
Yeah.
both cases, addition of water, that is known as hydration. The difference here we are heating, yes. And the reagents, that will be the difference.
Yeah.
Okay. Then next method, that is chlorination. So these first and second one, that is oxidation. Here it is chlorination. What do you mean by chlorination? Chlorination. That means addition of chlorine, isn't it? So these all methods, that's from hydrocarbons itself. First two methods are oxidation. First reagent is chromial chloride. Second one is chromic oxide. Okay. Then third method, that is chlorination. Whenever you see this chlorine as a reagent, the reaction will take place only in the presence of light. Okay, direct addition of chlorine to one molecule, that will take place only in the presence of light. So to indicate the presence of light, we will write this H nu in this arrow, H nu. That will represent the presence of light. Clear? So here the reagent is chlorine and it will take place in the presence of light. That's why H nu is there. And the first product formed is benzyl chloride. So instead of toluene, it will be converted to benzyl chloride. So 2 hydrogen atoms will be removed and 2 chlorine atoms will be added. So here it is CH3, it will be converted to CHCl2. That means 2 hydrogen atoms will be removed and 2 chlorine atoms will be added. So benzyl chloride is formed, and in the second step, again addition of water. And the temperature is 373 Kelvin. The product formed is benzaldehyde itself. Okay, so first two reactions, oxidation, you have to specifically learn the reagents. Okay, chromial chloride and chromium complex will be formed. Here it is chromic oxide and its complex will be formed. And the final product, the second step, the reagent is same in all these cases, addition of water. So this is the third method third method means first one that's from acyl chloride, second one from nitriles and esters. This is third one from hydrocarbons. Then one more reaction that comes under this hydrocarbons that we can learn. Have you completed this one? This is clear, children? Any doubt? Any doubt? Shall I move to next one?
Ma'am, like the last chapter notes, will you post them?
I will send the PDF. Okay. Then next one, that is the third one, that is also from hydrocarbons. And in the last three reactions, we had taken toluene, right? Here we are taking benzene. Instead of toluene, we are taking normal benzene. And the reaction is known as Gutterman-Koch reaction. Okay, the name of the reaction, Gutterman-Koch reaction. Here the reaction is very simple. We are taking benzene, then the reagents are carbon monoxide and hydrochloric acid. Okay, carbon monoxide and hydrochloric acid, these two are the reagents. The catalyst used is anhydrous aluminum chloride or cuprous chloride. Anhydrous aluminum chloride or cuprous chloride, that will be the catalyst. And the reagent is carbon monoxide and hydrochloric acid. Normal benzene, it will be directly converted to benzaldehyde. So this reaction is known as, the name of the reaction, that is Gutterman-Koch reaction. So when you see these two reagents, carbon monoxide and hydrochloric acid, in the presence of anhydrous aluminum chloride and or cuprous chloride, the product formed will be respective benzaldehyde. Benzene, it is converted to benzaldehyde. Clear? So these are the different preparation methods of aldehydes from hydrocarbons. Now the preparation of aldehydes, it is completed. So you have to remember all the preparation method. First one, that is from acid chloride, that is known as Rosenman reduction. Then second one, that is from nitriles and esters. From nitriles, it is known as Stephen reaction. Then the third one from hydrocarbons using chromial chloride, chromic oxide, that is by oxidation. Then the next one is chlorination. Then the next one, that is Gutterman-Koch reaction. We have to learn the reagents, catalyst, the final product, the steps. So write these reactions and learn. If you read the reactions and try to learn, it will not be possible to remember. So please write these reactions and study. Okay. So these are the different preparation methods of aldehydes. Next one is about the preparation of ketones. Okay, methods of preparation of ketones. Only three methods. The first one from acid chlorides or acyl chlorides. Okay, first one from acid chloride or acyl chloride. So in this one, the acyl chloride, the reagent is dialkyl cadmium. Dialkyl cadmium. The chemical formula R2CD. Dialkyl cadmium. So first we need to prepare this dialkyl cadmium. That is the first step. Here only simple reagent dialkyl cadmium, but we need to prepare dialkyl cadmium. That is the first step. So using Grignard reagent. What is the chemical formula of Grignard reagent? Correct. RMGX. X stands for any halogens. R stands for any alkyl group. So here RMGX, that will react with cadmium chloride, that is CdCl2. Okay, Grignard reagent that will react with cadmium chloride, then dialkyl cadmium will be formed. So that is the preparation method of dialkyl cadmium. Clear? Grignard reagent with cadmium chloride will give dialkyl cadmium. Then this dialkyl cadmium that will react with acid chloride and the respective ketones will be formed. So look at this reaction. Instead of this chlorine, this R group will substitute the position. Okay. Here RCOCl, that is acid chloride or acyl chloride. So instead of this chlorine, this alkyl group will replace this position. Then it will become RCOR. That is the chemical formula of ketone. These two R groups, maybe it will be same or different. Okay, R and R dash. R dash represent another alkyl group. So both the alkyl groups that can be same or different. So here the reagent is dialkyl cadmium, acid chloride. On reaction with dialkyl cadmium, respective ketones will be obtained. So the first step, that is for the preparation of dialkyl cadmium, that is by Grignard reagent and cadmium chloride. Clear? This is clear, children? First method. Then second one, that is from nitriles. Okay, that is from nitriles. So here one example is given, CH3, CH2, C triple bond N. Okay, so Cn, that will be the functional group for nitriles, that will react with Grignard reagent, C6H5 MgBr. RMGX, that's the general formula for Grignard reagent. Here we are taking one example, that is C6H5 MgBr in the presence of either. So what happens in this reaction? Look here, here it will be triple bond, right? C triple bond N. So one among this triple bond, it will break, and this MgBr, it will be attached to this carbon, and the C6H5 that also attached, this MgBr that is attached to this nitrogen, and the C6H5 that will be attached to carbon. So there is a triple bond between carbon and nitrogen. This triple bond breaks and it will be converted to double bond. So in order to maintain the valency, this MgBr that will be attached to nitrogen and C6H5 that will be attached to carbon. That is the second step. Second step means not second step, first step. Second one, second product. First, nitrile that is reacted with Grignard reagent in the presence of either, and this triple bond breaks, MgBr attached to nitrogen, then C6H5 attached to carbon. Then in the second step, addition of water. Okay, addition of water. So here, instead of this NMgBr, this oxygen will be attached to this double bond. On addition of water, oxygen will be attached to that double bond, and NMgBr, it will be removed. Clear? And the product formed is known as propiophenone. That is propiophenone. That will be the product. That is the common name, and its IUPAC name 1-phenyl propanone. That is the common name. 1-phenyl propanone. Because here this group is considered as a substituent phenyl group, and here it is C2H5C. So there are 3 carbon atoms. I will teach you the naming. Okay, IUPAC naming. Then you can able to write the names of any aldehydes and ketones. So here the common name is propiophenone, and its IUPAC name, that is 1-phenyl propanone. So this is the second method of preparation of ketone, that is from nitriles. This is clear? So here also the reagent is Grignard reagent in the presence of either. So triple bond breaks, MgBr adds to nitrogen, C6H5 to carbon. Then on addition with water, respective ketones will be formed. Clear? Then the third one, that is from benzene or substituted benzene. From benzene or substituted benzene. So here we are taking benzene and acyl chloride. Okay, acyl chloride and anhydrous aluminum chloride is taken. So can you tell me which type of reaction is this? Are you familiar with this reagents? Acyl chloride or acid chloride in the presence of anhydrous aluminum chloride. What will be the name of the reaction? You have learned the same reaction in the previous organic chemistry chapters. Do you remember? When you see any 2 reagents, if acid chloride or acyl chloride, okay, if it is aromatic, that is known as acyl chloride. If it is alkyl group is substituted here, that is acid chloride and anhydrous aluminium chloride. If these two reagents are present in a chemical reaction, it will be always Friedel-Crafts reaction. Okay, Friedel-Crafts reaction. So here the reagents are acid chloride and anhydrous aluminium chloride. So the ketone will be obtained. So this is the third method of preparation of ketones. That is from benzene or substituted benzene. Here the reagent is acid chloride in the presence of anhydrous aluminium chloride. So that's about the different preparation methods of ketones. Clear? The beginning, we learned about the common methods of preparation of aldehydes and ketones, then specific chemical reactions, the specific preparation methods of aldehydes. Then this one, that's about the preparation of ketones. This is clear? Any doubt? Any doubt, children? No, nothing.
Only can you explain the Gatterman-Koch reaction?
Gatterman-Koch reaction, it's very simple reaction. Benzene. Benzene will be the reactant. Okay. And the reagent is carbon monoxide and hydrochloric acid. Carbon monoxide and hydrochloric acid. And the catalyst used is aluminium chloride or cuprous chloride. Anhydrous aluminium chloride or cuprous chloride. What do you mean by anhydrous? Anhydrous means removal of water. Water is not will be there in aluminium chloride or cuprous chloride. The benzene that will be directly converted to benzaldehyde. That means CHO group will be attached to benzene. That is known as Gatterman-Koch reaction. Simple step. In a single step, you can write the reaction. No need to write the first step or second step. Only one reagent, carbon monoxide and hydrochloric acid, respective aldehyde will be obtained.
But so like it is given, it gives benzaldehyde or substituted benzaldehyde.
That
What is
depends upon the reactant taken.
No, but what is substituted?
Substituted means something will be there in that benzene ring. Example, toluene. Toluene is one example for substituted benzene.
Okay.
So if toluene is taken instead of benzene, I will show you one example. Wait. Okay, this one is toluene, right? CH3 group of benzene ring. And the reagent carbon monoxide and HCl, then anhydrous aluminium chloride or cuprous chloride is taken. Then the product will be substituted aldehyde. CH3 group will be there itself, then CHO will be there. Okay, so some other group is also there. That's why it is known as substituted benzaldehyde. Clear? Benzaldehyde is benzene ring with CHO. If there is any other group present in that benzene ring, that will be known as substituted benzaldehyde. Okay.
Yes.
Okay, then the remaining things we can discuss in the next class. Now let me take your attendance. Just wait. Okay. Okay, then thank you, children. See you in the next class. Bye.
Thank you, ma'am.
Thank you.